There it is.
We're up.
I think we're up.
We're live. Welcome if we just showed up in your... Are we there? We're up? Okay, we had a little bit of a rocky start, but here we are again. 3:30 as our regular shows are. We're doing a virtual science field trip again. And today's theme has started out something different. I wanted to redo things that I had failed at. And I did bring a couple of things in here. And I wanted to make a point about failure, because I think the last time I made this point about failure, saying science is built on failure, I was right. But I didn't add the second part, or the first part, if you will. Science is built on failure from a stubborn person who does not want to fail and wants to keep trying. And so the expert in how light bulbs don't work would be Thomas Edison, because he failed so many times, but ultimately he changed the world when he did succeed. So he knew he had something, and we too know we have something when we keep trying. So let's try working forward with today's theme, which is how we have a ball here at the Headwaters Science Center. Now, I brought a number of different kinds of balls into the scene here, and I'm going to use some slightly non-traditional ways to have fun with them. You know, a lot of you out there have various balls in your garage hanging around your house, and I'm going to use up the last of this very, very cold extra liquid cold nitrogen. I might as well give it all to myself, because this won't keep. And it is liquid, but then I'm going to tell you the story, and some of you know about liquid nitrogen. Oh, there we go. Sometimes it gathers in different places in the keg. This is a vacuum sealed, double, triple insulated steel canister that keeps it cold, extra cold for us, and it's minus 321 degrees below zero. I want you to note the top we use, which is porous and allows the gases, which are continuously forming off this liquid, even in this keg, in expanding into their gaseous form, which often is 6, 7, even 800 times more. Liquid nitrogen is around 700 times more space per molecule as a gas than when it's in this liquid form. All right, so I have some liquid nitrogen here, just to prove it. Let's bring it out into our stage. I like to keep the eyes protected, because in the end they are the most sensitive things. My skin isn't as hazardously in danger as some might expect, because it sort of boils off. It's called the Leidenfrost effect. Something similar to that. Leidenfrost effect, I think is how we get it. And when I put it in there, you notice something right away out there, in here you notice it's boiling. And I talked to you about it being minus 321 degrees below zero, and this is boiling. And I know when we organize our brains, we have categories of things. And somewhere in most people's brain, there's a category for boiling, and right next to it, they might have another category for warm. Well, this is boiling at minus 321 degrees below zero. As it warms up, it goes from a liquid into a gas, and it takes up that extra space, which the room allows. So, what is boiling? Let's reboot the idea about what is boiling. Boiling isn't just hot. Boiling is something turning from a liquid into a gas, and that does take energy to do, and so this will show that energy as well. And I always like the way it looks coming out of there, so I'm going to seed that up a little more. Am I missing it? Or there, I'm hitting it. So I just like the way it looks in there. I had to bring that along. Keep your eyeballs on that. That's another way we have fun around here with our eyes, seeing all the different things. Now, while a balloon isn't really a ball, it's spherical, and that's really what we're going to be talking about, our spherical items. It floats. This is a helium balloon. So we can make general presumptions sometimes about helium balloons float. And that's true. But the truer thing we should say is that helium balloons sometimes float. And they don't float when they're that size, but they do float when the gases stretch back out and take up enough space. I don't want to move it out a little bit so it has its rise. Enough space so that it indeed is lighter than the same amount of air that it displaces. floating in air is a lot like floating in water. When you're lighter than the same amount of water, this would easily float in water. Well, actually it would float through the water and come out of the water, I think, because it's much lighter than the same amount of water would be. All right, so there's that. We'll do that one more time just because I just like the sound of that brain-looking thing re-inflating itself. And to remind myself that helium balloons sometimes float, that there's physics at work all the time giving us different, oh, and so it rises gently up to us as it gets to the size that I want it. Okay, so let me see about this. This was something I wanted to try too. Here's my set of interesting balls that I'm going to mess around with and put some of those free on the table here. Oh, I wanted to bring this ball up. This is one I found when I was looking through the box of balls. This is the Buckyball. Now imagine this nano-sized, built from actual atoms of carbon. These are used to deliver drugs. They're strong and stable, and you can make a Buckyball out of carbon atoms and create a very strong spherical shaped drug delivery, or some other way that you can want to get some item into a place where it's hard to get, and you also need to be stable. So there's that. I just wanted to show you that because I thought Buckyballs are cool. All right, now these balls, get your eye on that one, are bouncy balls, and they have this elastic characteristic. Let's put them in there and see what happens with that. Well, yeah, tongs out of here. I'm just getting up those. So they're in here, boiling away. And by boiling, I mean they're giving the heat that they have, which is the room temperature heat, to the minus 321 degrees below zero liquid nitrogen, and in the process, their temperature is dropping. So we're not adding cold to these balls, we're subtracting the heat from them. And that's the only way this thing works in this universe. Maybe in a parallel universe it works differently. I know the rules of physics are still open to suggestion by some, but in the universe that I've been in, that will only give you heat in that direction. Now, air conditioners work this way. They take the heat out of the room. They don't really add the cold to it. So in the process of being that, it changed drastically how it acts, how it sounds. Even though it didn't change much size, it still has a very different, it's a nice sound for the clinks on the plate. I didn't expect that. All right, let's try this. Oh, here was one that this was one where I was going to try to right myself. I was going to use the liquid nitrogen to do it because, oh, by the way, I'm going to, the last time I didn't bring enough different examples to the show, so I'm going to try a lot of these kinds of different balls. And I'm going to put these into the liquid nitrogen and see what happens. Now, they should actually have I'm going to sink them in here. They should have, they're boiling away, and they should have, there's a negative pressure, so they're going to draw some liquid nitrogen into themselves. And then we'll see if we can get these to do what I've been wanting them to do. Put that one out there and see if it'll go. There it's going. That one's starting. And you can see it spinning and gathering up some speed. I don't know which one works anymore because I tried so many different ways to do this. I've got big holes and small holes. And that first one I put down is still spinning. First one's doing the best job so far, so let's watch that one play. I remember loving this trick because it shows, maybe the camera doesn't quite see it, but let's see if we can have some more interplay with the other balls on there. This one's kind of my best one so far, so I'm going to keep that one aside and put that one in the kit. How about this one? Oh, here was one I drew up on. Let's see how that works. I can touch this stuff for just a second or so because, well, after all, we just got through a winter where it was much. So far, this is the winning ball. So what I did was I put a small pinhole into these ping pong balls, and in that, so doing, it allows the liquid nitrogen in, and it gives it the play. So far, this is the only one I really will stand behind as a good spinner. Yeah, it's in my pocket right now. I'm keeping it apart because it looks so much like the others. Now that one spit out a lot of its nitrogen all at once, but it doesn't seem to be particularly excited to keep going. There it wants to sort of jiggle-juggy around on the, here's one, on the plate. Ah, it's spitting at me. I can feel the, there it's going, the one I gave up on. Just had to get it angled right. The first one was still the winner. Now maybe there is a bit of luck involved in making this one work, but I did fail at this the last time, and I don't know that I succeeded, but I don't think I failed either, so I forgot about that middle ground, which is a big part of what goes on too, that sort of maybe place. All right, let's go back to the one we liked, or at least the one I liked. See if we can give that one to give us a full ride. We can look at it and see what I did to that one. I have small holes in that one. Give it a little bit more time in the nitrogen. And let's see. There it goes. And you can see it has two, at least two, I don't know if this one's the one or the two. I'll have to investigate the ball afterward. A jet, small jet holes that are sort of tangential to the ball, and they're making it spin like crazy. We can, since that's our good example, it's still spinning. And the plate's not a bad place to do it on. So that's given us a nice little show. And that's the winner. The ball was the winner. I just was knocking holes in these last about 10 minutes ago. And I either got lucky or did just the right thing on that one. You know, sometimes luck is better than skill, as I've been known to say before. I wanted to try this other thing. I don't mind trying things live, and does it work or not, because let's face it, that's how we do things when we try things. But I thought maybe this would give us an interesting effect. It's different. I don't know. It's a ball, and we're playing with it. So at least we've got that going on. That one doesn't bounce so well. This one should be too small. It goes through. This heavy one? Yeah, that won't do it. Here's a nice light one. Let's see how that one dances. So far I think I like this one, even though it's the same ball, it seems to dance differently. Oh, there was something else I wanted to bring along. We have that way to launch a ball. Now that's interesting enough, but it's not that interesting. Here's what I found was more fun. If you get it, let's try one first. It sort of has the nozzle is kind of small, so it gives it a launch. And if you see, the ball actually goes further because we hold it back a little bit. I'm going to sort of shoot it towards the camera, see how that goes. So we hold it back a little bit of time, and it actually goes further. All right, let's try that. Now, the thing I really wanted to do with the leaf blower was this way of starting up the idea of the Bernoulli versus the Coanda effect. Around 45 here where it will not hold that in, why oh why? That's about as far as you can take it, all the way to here. Now there's plenty of space beneath it to fall. Why does it stay up? Some would say, oh, it's the Bernoulli effect. Well, maybe. I don't personally agree with it. I'm a Coanda effect guy. The Bernoulli effect suggests that when you speed around something, you lower the pressure. That is true, but Bernoulli himself would suggest that that has to do with one fluid in one system, and then when we do these kinds of things like we're doing now.
Request. Are you ready?
Okay.
Let's see if you can catch it in the air.
Oh, that's gonna be tricky. We'll see.
Put it up.
Give me a good lob, anyways.
All right, here we go. All right. More of that after the show.
More of that after the show. Let's try another one. This one might be easier to catch. Oh, bad toss over to my.
Here we go.
Get it up and lock it. Oh, I needed to run around and dig the job a little bit more. So let's try the smaller one and see if we can exploit that notion. Now, the Coanda effect has this idea that when something's out like that, that there's There's air that actually sticks to the bottom side, and that's what creates the low pressure, that the pressures around it are similar to where they were before, and that low. We've got a wire in the here. Do you see that wire finagling with us there? You didn't, but we did it. We did here. Well, the little one's not as mindful as the other one is. The other one seems to want to play along a little bit. Let's try this one out again. Differently than the odder shaped ones. Now, one question that should come up to everyone here is, why are there so many things in the shape of a sphere? Why is the earth like a sphere? Why are stones often a sphere? Why are so many things in this shape? And why are bubbles in a sphere? And it's because that's the low energy state. That's the easiest shape to hold yourself into. So if you wanted to go out here and try and create a triangle, that would take a little bit of maneuvering on that substance, whereas the spherical shape sort of comes back in and holds itself into itself. So pressure easier, more predictably than oddish shaped items. For instance, this blow-up ball, which isn't quite right. All right, let's turn our camera around and look over here at the exhibit that we have here. I'm gonna try this trick. Okay, you turn and I'm gonna stay with the camera. I wanna see if we're still moving, so we're still going. Now we're here at the Science Center have this device, the Bernoulli ball exhibit, but as I'd like to start a conversation among physicists, aerospace engineers, whoever wants to join in with us about whether indeed this is the Bernoulli effect. So we send that up, and with the Bernoulli effect, we can see those similar things we were seeing with the leaf blower. But my Earth is heavier than this ball, it turns out. This is the one we typically do here. Let's see if we can't get some more. More than one ball up at the same time. Look, I would have put up there and banked it. Bounced right off. The heavy ball. Let's put this one up. Take this one out. Where'd my little one go? Did you see it? Oh, this is a timed exhibit, by the way, so I have to do it in about 20 seconds before it shuts off. You see one somewhere underneath? There it is. So, again, we've been trying all week to get two balls up. That one's not letting us do it. Where's that one that we like, that super ball, that really round one? I knew this would happen, that we'd have balls all over the place. We might lose the one we wanted. This is not the first ball I've lost today, surprisingly. There was the one that was good, the one super round one, and see if that gives us more response, and maybe we can get two up with that. I think I might have sent that off over. There's no one on camera, but there is now. So we'll skip past that. It was just an idea, a fleeting notion. What we really wanted to show as we were going through trying to do some kooky things with balls, we said, well, let's get some different size balls. This was actually a suggestion of one of our board members. Yes, thanks for playing in the game with us. And we ended up, did you shop this out? Someone got us this nice big ball, and we thought, oh, well, that's going to show us something, but we didn't know what it would show us. So let's just show you what we've seen when we did that. We see it kind of have a curious, weird, unexpected, really, the ball is the star, I stand back. I yield to it. I'm not exactly sure all the physics going on there, but there's a lot of dance and a lot of art, so we're looking at that ball right there. Ladies and gentlemen, that's that's how we have a ball at the Headwater Science Center. So come on in and visit us for real, because we're opening it up now, and we're going to figure this stuff out in real time with you. I'm out.
James Owens today, he was doing our 3:30 show, and that was so much fun. We will guarantee you, if you come in, we will let you use a variety of balls on this particular exhibit. And we are open Friday, Saturday, Sundays, and Mondays, 9:30 to 5:30 on Friday, Saturdays, and Mondays. Sunday, we're open in the afternoon from 1 to 5:30. So what are we doing on Tuesday, Wednesdays, and Thursdays? We're having groups, field trips specifically. So, you can come in on Tuesday, Wednesday, Thursday, and particular class. It's called Let's Get That Picture. That is just about right next to it.
We're going to get out here and trace some of these air patterns to see if we can call out Kowanda or Bernoulli, and all we ended up doing was finding a way to dance with the ball when we did it.
Alright, sign it off. Next, it's going to be nice show.
Well, gave you about as much show to do. I did you want a ping pong ball to go? Now I gotta look at it and see if we can figure out why. I don't know where.
Yeah. How do we get this?
Did wipe out one failure.
How do we get this camera to zoom?
It
That
will
would be
be
so cool if you could just like zoom, because I would have zoomed in on that plate. That would have been very cool.
Yeah. It should have a digital zoom in it, but I'm not. Are we still putting out the same?
I think, yeah.